All right, a mole. Not this cute little mole here, but we're going to talk chemistry mole today. Are you ready? All right, pause it, peruse it, look around. All right, so let's start with counting units. We should know some counting units. Like, a dozen means 12, even though you can have a dozen bagels, a dozen eggs, a dozen cupcakes, it still means 12. A ream is 500, so a ream of paper, 500 sheets. A pair means 2. If you say, like, get me a pair of shoes, nobody brings you 8 shoes, okay? A pair is 2. Gross means 144. That's how a lot of things are packaged. Hat trick is 3. The mole is simply a counting unit used in chemistry. So it is found on table D. It means amount of substance. So a mole is a counting unit. It's the SI unit for amount of a substance. It is abbreviated MOL, not M, MOL. M is meter, so you can't abbreviate it that way. It means 6.02 times 10 to the 23rd particles. So for a dozen, you only have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. To get to a mole, you would have to count 1, 2, 3, 4, 5, 6. I'm going to count it all the way to 6.02 times 10 to the 23rd. That's a lot. So instead of representing it as the written number, we call it a mole. It is based on the number of particles in 12 grams of carbon-12. So that's where it comes from. 6.02 times 10 to the 23rd particles per mole is Avogadro's number. It is named after Amedeo Avogadro, but it wasn't discovered by him. So molar mass. Molar mass is the mass of 1 mole of a substance. It's also called gram formula mass. It's also called formula mass. So molar mass, gram formula mass, and formula mass are all literally the same thing. And the units are grams per mole. So 1 mole of carbon-12 has a mass of 12 grams and 6.02 times 10 to the 23rd particles. So that's where it's all connected. That's where it all comes from. So other substances will have different molar masses because they're not carbon-12, okay? So for example, oxygen as a diatomic molecule will have a mass of about 32 grams. Carbon dioxide will have a mass of about 44 grams. A mole of copper, just as single atoms, not bonded, will have a mass of around 63.5 grams. So a mole is the number of particles. We had to count up to 6.02 times 10 to the 23rd particles. And if we mass that number of particles, each substance is going to have a unique and different molar mass. So again, you can see a mole of different substances is not the same amount. If we look at the number of particles, it would be the same. If it's 1 mole, it's 6.02 times 10 to the 23rd particles. It's just that the mass and the volume, the size could be different. Because not all particles are the same size. Not all particles have the same mass. Different elements have a different mass. Here are some other examples you can see based on amount, based on mass, different elements, different substances are going to have a different molar mass, a different gram of formula mass, a different formula mass. So where do those numbers for molar mass, the gram formula mass, the formula mass come from? Well, for monatomic elements, it's easy peasy. It's literally right on the periodic table. So finding the molar mass, the formula mass, the gram formula mass for simply a monatomic element, like this. And if you forget what elements the entire periodic table is based on, it tells you right here, relative atomic masses are based on carbon-12. Also, carbon is the key, okay? So here's where we're looking to find the gram formula mass, the molar mass, the formula mass for monatomic elements. So, and we're going to round for our purposes to the decimal place of tenths. So 1 digit after the decimal. If it rounds to a whole number, you don't need to write 0.0, you can just write the whole number. So let's look at sodium. Here is its its atomic mass, so its gram formula mass would be just 23. What about magnesium? What would its gram formula mass, molar mass be? 24.3 grams per mole. And what about for lithium? Right here, it would be 6.9 grams per mole. So 1 mole of boron, what is its molar mass? Well, there you go, 10.8 grams. How many atoms does it have? Well, since it's 1 mole, it's 6.02 times 10 to the 23rd. What if I have instead a mole of argon? What is its molar mass? Well, right there, its gram formula mass, its formula mass, its molar mass, 39.9 grams. And how many atoms are in that mole? 6.02 times 10 to the 23rd. What if instead we have 1 mole of silicone? Well, its molar mass, 28.1 grams. How many atoms? Well, since it's 1 mole, it's 6.02 times 10 to the 23rd. Now, finding the molar mass, the gram formula mass, the formula mass for diatomic elements requires a little bit of math. We'll still use the periodic table though. So the subscripts matter. So if we have 1 mole of chlorine gas, we actually have 2 moles of chlorine atoms because of this subscript. So if we have 1 mole of O2, what does that subscript mean? Well, that subscript means that we actually have 2 moles of oxygen atoms in that 1 mole of oxygen gas. So what is its molar mass? Well, if it were 1 oxygen atom, it would be 16, but I have 2 of them, so I multiply it by 2. How many molecules do we have? Well, the molecules is the whole package. So I have 6.02 times 10 to the 23rd because I have a mole. But how many atoms? Well, I would have 2 times the 6.02 times 10 to the 23rd. Okay? So to do this, I just multiplied these 2 numbers together to get this. And then I had to move the decimal point 1 place to the left, which means this exponent went up 1. Okay. What about if I have a mole of Cl2? Well, what does the subscript mean? Well, if I have a mole of Cl2, I actually have 2 moles of chlorine atoms. What is its molar mass? Well, if it were 1 mole of atoms, it would be 35.5, but it's not. It's 2 moles of atoms, so I'm going to multiply it by 2. How many molecules? So the whole package, since it's a mole, I have 6.02 times 10 to the 23rd. How many atoms? You do the same thing. We multiply these 2 numbers together, leave the exponent alone, but I have to move the decimal 1 place. This direction, that means the exponent goes up 1. All right, now finding the molar mass, formula mass, gram formula mass for ionic compounds also requires math. So if I have MgF2, what about the subscripts? Well, I have 1 mole of magnesium ions and 2 moles of fluoride ions. So what is its molar mass? Well, 1 magnesium plus 2 fluorines. So I have to multiply fluorine times 2, add it all together, okay? How many formula units? Well, formula units is the whole package. So since it's a mole, I have 6.02 times 10 to the 23rd. What about how many ions? Well, since I had 1 mole of these and 2 moles of these, that's 3 moles altogether. So I took this and multiplied it by 3. I have to move the decimal 1 this way, which means the exponent goes up 1. What about if I have Al2O3? What do the subscripts mean? Well, 2 moles of aluminum ions and 3 moles of oxygen ions. So what's its molar mass? 2 aluminums and 3 oxygens. So I have to multiply aluminum times 2 and oxygen times 3. How many formula units? Well, since it's a mole, I have 6.02 times 10 to the 23rd formula units. How many ions? This time I have 5 total ions, so I have to multiply by 5 and do the same thing I've been doing. If we do it for covalent and molecular compounds, it also requires math. So in this compound, what is the ratio of aluminum to oxygen? So to do that, I look at how many aluminums, 2. How many oxygen, 3. So the ratio of aluminum to oxygen is 2 to 3, or 2, or written like this. Okay, but they wrote out all the words. These subscripts, remember, do not represent grams. So these are wrong. They represent moles. So how many? We had 2 of aluminum to 3 of oxygen. All right, so 1 mole of C2H6. So let's see, what do the subscripts mean? Well, I have 2 moles of carbon atoms and 6 moles of hydrogen atoms. What is its molar mass? Well, carbon has to be multiplied by 2. Hydrogen has to be multiplied by 6. How many molecules? Well, since it's a mole, I have 6.02 times 10 to the 23rd molecules. How many atoms? I got to do math. I take 8 because I had 6 plus 2 total, multiply it, move the decimal, raise the exponent, same as before. What about CF4? What do the subscripts mean? Well, I have 1 mole of carbon atoms and 4 moles of fluorine atoms. What is its molar mass? Well, 1 carbon and 4 fluorines. How many molecules? Since it's a mole, I have 6.02 times 10 to the 23rd molecules. But if I want to count atoms, I need to add up the total number of atoms, which in this case is 5. And then I adjust decimal and exponent like before. Okay, let's try a couple of harder problems. So what is the gram formula mass of, yikes, this whole thing? Well, I can tell you just at quick glance, I have calcium, phosphorus, and oxygen. Calcium, I have 3 of them. Phosphorus, 1 inside, but I have to multiply it by 2, so I have 2. Oxygen, 4 inside, but I have to multiply it by this 2, so I have 8. Okay, so I have to find on the periodic table the molar mass, and I multiply. So I do that. Now what do? Add it all up, and you get this, which sometimes when this happens, we don't get an answer that is exact. This is not up here. But what is the closest answer? Be logical. There you go. All right, what about the molar mass of this? Well, my elements, I have Ba, I have O, I have H. How many Ba's? 1. How many oxygen? 1 inside, but times 2. Hydrogen, 1 inside, but times 2. So barium, oxygen, hydrogen. To get the gram formula mass, the molar mass, the formula mass, gram formula mass, molar mass, all the same thing, add it up. So you get this, which does exactly match. So there you go.
In your own time, but quite quickly.
Now you're going to be doing some practice on your own. But that's it. That's all about a mole. I hope you learned something new today.